Today's the day that you set yourself apart. You really wire this thing up for good, and you should be able to test everything. It looks super intimidating when you see all these wires going every which way, but if you take it step by step, it's not nearly as bad as you might think. I've color-coded the wires to make life easy. I'm going to do my absolute best to show you visually everything that you need to know without any nonsense, and you can wire these up very quickly. Number one, make sure you use solid core wire and strip the ends of all your wires, have all your wires ready to go before you try to do these hookups. It'll make your life easy. You're going to need 3 long wires, about 18 inches long. If you can, I would recommend that you use 3 different colors. If possible, a green, a red, a black. You're going to need 3 jumper wires, maybe about 3 inches long. Strip off both ends, and that should get you going in the right direction. I mentioned this in another video, but I'll mention it again. On your stepper motor driver, make sure that you flip the switch so it's over to 5 volts on the top of it. That is critical. There's a bunch of switches on the side that configure this stepper motor driver to behave in the way that we want to. All the code for all of this is on the front side of the stepper motor driver that I recommended, the DM542T. I'm going to give you the shortened version of all this. You want the switches being off, on, off, on, and that will be a very conservative setting with current. It will set at 2.37 amps for output current. It will hold the central current idle, and it will set the microstepping to 1600 microsteps, which is little increments that it goes to complete 1 revolution when it turns the top of your stepper motor. And based upon that and your pitch of your lead screw, that will determine how many millimeters it moves per revolution. This thing's hooked up, and so for the simplest way, start with those settings. If you want to in the future, feel free to reconfigure this. Now, I'm going to simplify things down for this video just a little bit. So these are all the wires that we hooked up before in the last video. If you haven't seen that, watch it, follow all the safety guidelines that are there. But one of the beauty of these stepper drivers is you can pull the plugs out, so I can remove all these wires. The next thing is we've got some alarm pins that are on here. We're not going to actually be hooking any wires to it, so I'm going to remove this and I'll put this plug back in at the very end. And then finally we have these, and what you're going to find is there's going to be 3 long wires that are going to be going over directly to our Arduino Uno shield in very particular positions based upon which axis of the CNC that this motor driver is going to be controlling. And they're going to be coming off the first 3 pins here. And then we're going to have 3 little loops of wire that are going to be bridging between these other pins. That means that some of these pins here will have 2 wires twisted together, and some of them will be all by themselves. And in fact, the only ones that are going to be by themselves, the pull plus, the direction plus, and the enable plus will have a single wire. All the other pins are going to have 2 wires twisted together. So here's our stepper motor driver. These are the wires that we hooked up the other day, and I just pulled the plug out so that it declutters. There's a little tiny plug that went with the alarm plus and alarm minus. We're not going to be hooking any wires to that right now, so I removed this plug as well and just set it to the side. And what I've got right here is the wiring that we need to do for the x-axis. So on my stepper motor, starting at the enable minus, I'm going to work through each of the connections that you need to make, and I'm not going to explain all the reason why we're making them this way, but I'm just going to give you how to make the connections right now and leave it at that for the moment. So with that being said, let's start on the far left hand side. And the far left hand side, I've got a loop of wire, and your wire you want to have a length that's stripped on both sides that maybe is about 3 inches long. It doesn't really matter, but it's sufficient that it's easy to loop between things, but not so short that it's difficult to, remove the insulation on both sides. So you're going to need 3 pieces of wire like this. You can use whatever colors you want. I chose to use different colors for the bridges so that you can see more easily what's going on with the pins. And into slot number 1, which is the enable minus, we've got 2 wires hooked on there. We've got 1 wire that is a green wire and 1 that's a black. And what I would do when you have 2 wires going into something, I would twist those wires together and then crimp them down. Now, the other end of the green wire is going to be put all by itself into the enable plus. And then we're going to go over to the next scenario. And so here's our black wire coming out of pin enable minus, and it's going to jump past the green, second slot, and it's going to go over, and we're going to hook it into the direction minus, and we're going to twist it onto another bridge wire, which in this case is a white colored wire. And so we'll twist those 2 and we'll fasten it. And then the next slot over, we will have a long wire that's going to go directly out to our shield on our Arduino Uno. And so this particular one that's going out is coming off our direction plus. I've got it as a black wire, and that is going to go out to pin number 5. Then the next slot over, we're going to twist on the other part of this bridge, and we're going to twist it onto a long wire. I chose to use green because that long wire is going to get taken out to the shield, and we're going to hook it to a ground pin on our shield. And then finally, the last slot is a long wire all by itself, which I chose to do in red. And that red wire is going to go out to pin number 2 of our Arduino shield. So it doesn't matter. Let me just scoot the Arduino shield over so I have something like this. I chose at random the ground pin to put it in. It doesn't matter. But it does matter, of course, that that pull plus long wire, the very, very first pin, goes to pin number 2 if we're doing the x-axis. And it does matter that the direction plus long wire goes to pin number 5 for the x-axis. Everything that we just did, the only thing that changes when you change axes is which pins we hook them to. And so, for example, if I'm going to do my y-axis, I'm going to hook into pin number 3 and 6. And it, if I use the same coding scheme, it would be a red wire, and then this one would be a black wire. And so it's kind of convenient when you're sorting these out if you could use 3 different colors, of wire. The greens always being the ground, the reds always representing coming from the pull plus, and the black solid core wires coming from the direction plus pin. And with the y-axis, since we're going to have 2 of these stepper motor drivers that are going to be hooked up, you will actually have to twist on and put 2 connectors into the pin, number 3 and the pin 6, and then that other end of these wires would go to their corresponding stepper motor driver. And then, finally your z-axis is going to be pin 4 and pin 7 for those. And that's pretty much the name of the game, just in making sure that when you pinch these things down in here, that you make sure that the wire is actually getting sandwiched in the garage door. Make sure you're going righty-tighty, lefty-loosey. It is possible on these shields for you to pin a wire below the garage door and not have a good connection. So make sure you did indeed turn it to the right. And once again, for the other grounds, just put it to a different ground pin. One huge advantage of doing this shield is it gives you lots of slots for your grounds, and that makes it really, really nice when you hook this all up. And then literally, that's all there is. I mean, it looks super intimidating, but once you know how to do those pins, and then I would recommend once you get all done, you're going to go ahead and I would put this alarm pin in. If I can finagle it in, got to turn it the right direction. So slip it back in there after you've assembled it. And then if you already had wired your other part of your CNC that I showed you how to do in the other, you can go ahead and slip this back in as well. And one last thing, don't forget, I told you in the last video, but don't forget this top part here has to be set over to 5 volts because everything that's coming out of this Arduino Uno is coming out at 5 volts and it's sending the signals into this at 5 volts. That's what that scenario is setting up. Super, super important. We should be able to now hook a USB 2 cable to this, go back into GSENDER that I showed you how to work the other day. We've already flashed GRBL onto this, GRBL, and we should be able to connect. And if we hook this into our power supply and we made all the connections right, we should be able to toggle and make this thing run. So let's see if we can make our axes of our CNC run for the first time. This is a huge leap forward. It's the most intimidating. This is where most people give up. I hope that me using different color wires and really walking you through step by step really helped you, because it's so hard to get good, input on all this stuff. Or double check your switches. Use this configuration: up, which is off, and then pin 3, 4, down, which is on, pin 5, 6, up, which is off, and then pin 7 and 8, down, which is on. You might want to consider doing, because you're going to have 4 of these, just to keep them straight. Take a piece of painter's tape and slap on whatever axes that this is going to represent your CNC. And so if I was to label this with blue painter's tape or masking tape, it doesn't matter. I might just put X, and then I go pull plus, and I would go 2. I'd put pull minus ground and direction plus 5. And that way, if you need to go back and resort out any connections, you know what those wires, these long wires on here, were supposed to go to. If a wire ever gets pulled off, it makes your life so much easier, because you're going, okay, which one is missing? And things like vacuum hoses and stuff like that can snag these wires if you're not careful. Trust me, it's going to save you a lot of headaches. So just put a little piece of masking tape. And the other thing is, you will have, which axis is which when you're trying to figure out where to put these motors on your main CNC. So this is the first time I've turned on my power supply. You'll note that I unhooked the V plus and the V minus. I still have my power cord hooked up with the black to the line, with the white to the neutral, the green to the ground. And I'm putting in a line that has a fuse inside of it. This is just an extension cord reel. This is really handy. It's something you might want to consider, especially if you're going to have your CNC on a rolling cart. I still have a fuse breaker on my main panel, but this one has a fuse breaker at 13 amps. So I can run up to 13 amps through here. And so it's just one more redundancy. This is really quite nice for what we're doing. So you might want to think about something like this. And then I've hooked up a voltmeter. I set the voltmeter to the setting for the DCV, and I want it set it on mine at 200. It's got to be, less than the max and more than the minimum, and I'm expecting a volt reading greater than 20, somewhere between 20 and 200. So I'm going to use the higher value. I'm going to use 200. And then what I did is, just like we hooked the wires before, with this thing unplugged, not on, I hooked up the leads of this, and one of them I put to a V minus, one of them I put to the V plus, and I just screwed down those leads directly on there. And now I'm going to flip it on for the first time, and we're going to see what volt reading. Even though this is rated at 36 volts, there's a tiny adjustment screw on the left-hand side that we can micro adjust. Now, honestly, I don't really care. As long as I'm over 24 volts and less than 36, it should be fine for what we're doing. I normally run my CNC at 24 volts. So let's see where this comes in at. And I'm going to flip this on, and if all is well and we wired everything correctly, we should have a green light come on in this power supply. So let's flip it on. And the good news is I see a green light. I also see that I'm getting a volt reading. In this case, it's 27.1. If I shut this all the way down, you'll see that it takes just a little bit of time for it to leak the voltage back off. And then if I wanted to, I could go over to this screw on the far left-hand side and I could twist it to the right to turn up the voltage and twist it to the left to turn down. I think I'm fine running this at 27 volts for what I'm doing. I know that this can handle up to 36, and I know from experience that it can run it at 24. So we're right in that range, so I'm not gonna worry about that. And now I'm gonna go ahead and just unplug this so that there's zero power getting through. I'm gonna undo these leads to this voltmeter. So the very first time, it's probably a good idea to definitely check to make sure that the voltage that you're getting off the power supply is what you think it's going to be. And then with that still unplugged, we're gonna re-hook up the main wires that we had off of our plug. And if you recall, in the last video, the green wire we always had at the ground. So I'm going to hook this into a V- terminal, and I'll just put it in the, slip it under the metal plate. I don't have a round connector on this, so loosen it up and slip it on the right-hand side. Spin it to the right until it's a nice tight fit. And once again, this is all unplugged when I'm doing this. This one I did have a round connector on. It doesn't matter which, V- that we put the ground on, the green wire, and it doesn't matter which of the V pluses we put this one on. I'm gonna go ahead and put it on the one right here, because this screw's almost all the way out. So I have to take the plate all the way off because of the type of connector. And we will slip this on there. And it's a little tricky with the video. Sorry, I'm sure I'm blocking your view. But I've got it screw repositioned in that connector right on there. And I tug on it gently. Those look good. I still haven't plugged this back into my stepper motor driver. This is a Raspberry Pi 400. You could hook up with whatever computer. You're going to do it exactly the way you flashed it in an earlier video, but you're going to go into your GSENDER however you did that before on whatever computer. And then we have already hooked up the USB 2 cable. The A side goes into your computer. The B side goes into your Arduino shield. Have your power off when you hook all these wires up. And then I have my power supply over on the far side. It's already turned on. I've already got all my wires set up. I know I'm going to get 27 volts, which is in the right range. This driver is capable of handling anything from 18 to 50 volts, so we should be good. I know it'll run at 24 because I've done it before. You could dial it up to 36, but don't go above the whatever rating is on your particular stepper motor. But then all you have to do to make this thing work is connect to machine just like you did before. And if you have that USB cable hooked up and you've got your power supply on and you made all the connections right, you're going to come over here to jog control right here. And you could do any of these, but let's go ahead and do rapid because it does, faster spins. And we know we wired it for the x-axis because we use pins 2, 5, and ground. And I'm just going to click on this plus, and what we hope to see is that over here that this flag of painter's tape will turn on the shaft of the motor. So let's do it. And then if I click on the minus side, it should turn the other way. We don't care right now about how far it goes in which direction. We can get that later, and ultimately we'll go up here into firmware in a later video, and we're going to dial in very specifics on all these parameters. But with what you've got right now, you've just proven that you can communicate. And if you just put another stepper driver and rewire the pins, so instead of doing pin 2, 5 and ground, you do 3, 6 and ground, and all the other wire connections the same, then you've got your y-axis, and the same for the Z, and you could actually test all 3 of them here. I wouldn't, because right now I just have the stepper motor hooked directly into the main driver, but we're going to actually put a shielded cable on that eventually. So I wouldn't go to too much work of messing with this, other than verifying that you actually are getting movement here. And if you have that, then I think you're good to go. We'll deal with the shielded cable at our later time. If you like this video, please hit like. I'd really appreciate it. Leave a comment. I'm going to disconnect. I'm going to turn off my fused power supply. I'm going to unplug it. I'm going to unhook my USB cable, and I think we're set.